find all points, where they're saying points, that means they're looking for an xy coordinate point. On the graph of the given function where the tangent line is horizontal. Tangent line is horizontal. Horizontal means that the slope of the tangent equals 0. That's a horizontal line. Horizontal line has a slope of 0. Slope of the tangent line is f prime of x. So in order to find, I'm going to have to, the issue is, I'm going to have to take the derivative and set it equal to 0. And solve for x. Now that will give me the x values where the slope of the tangent line is horizontal. That's what it will give me. That's going to be our chant, by the way, for chapter 3. So here we go. We have to take the derivative of that sucker and set it equal to 0. That is product rule. So f prime of x equals the derivative of the first times the second plus the first times the derivative of the second. The derivative of x minus 1 is 1 times the second plus x minus 1 times, what's the derivative of x squared minus 8x plus 7? 2x minus 8. Now I'm going to have to take that guy and set it equal to 0. So that x squared minus 8x plus 7 plus x minus 1 times 2x minus 8 equals 0. That's an equation to solve. Order of operation says I've got to remove, yes?
Wouldn't that first factor with x minus 1 end up being 0 because the derivative of x would be 1?
No, because the derivative of x is 1.
So 1 minus 1 is 0, right?
No, because the derivative of x is 1. The derivative of 1 is 0. So that 1 minus 0 is 1. Yeah. So now I have to clear parentheses. For this guy, 2x squared minus 2x minus 8x plus 8. 2x squared plus 1x squared is 3x squared. Minus 8 minus 8 minus 2, that's 16, and 2 is 18. And 7 plus 8 is 15. Now I could either try to factor that as it stands, or what do I notice it has? Greatest common factor of 3. X squared minus 6x plus 5 equals 0. That makes life easier in terms of factorization. This is x minus 5, x minus 1. So the x values, what are these? These are the x values where the slope of the tangent equals 0. Now, they don't want the x values. They say they want what? Points. So they want points. So that means I need y values. So I'm going to be looking for f of 5, which is going to be 5 minus 1 times 5 squared minus 8 times 5 plus 7. And since I did this problem last hour, it's negative 32. It's not that I'm that smart. So the point is 5, negative 32. And then I need to calculate out f of 1. This was my favorite. It's 1 minus 1. 1 squared minus 8 times 1 plus 7. Well, this is 0, right, times whatever anything is. So it's 0. Now, what are those? Those are the points on the graph where the slope of the tangent equals 0. So those are the coordinate points. What did we find? Well, if I were to take a look at the graph of this guy, and that happens to be this one right here. Now, I messed around with this last hour, so I always start out, by the way, doing a zoom standard, zoom 6. What that does is that brings my XY axis to the center. Notice what's happening at x equal 1. Notice that? I have got a heel there. It's a hump at x equal 1. X equal 1, y equals 0. Now they say the other guy is at x equal 5, x equal negative 32. Zoom standard, by the way, the graph paper is minus 10, 10, minus 10, 10. That's what the graph paper looks like. And that means a y value of negative 32 is not going to be in that window. I have to increase my y's till I get it down to at least negative 32. So I'm going to set my y value on the minimum to be negative 40. And what that does is whatever is going on at 5, negative 32, I'm going to be able to see it. Because it told me that the slope of the tangent line was 0 at 5, negative 32. So now I'll just go ahead and graph. There is x equal 1. There's y equal, and if I take a look at, I'm going to draw a vertical line. I'm going to watch to see where I'm close to 1. Looks like about right there. And go a little bit more. There I'm close to 1. Notice that it has a hill. Anybody remember what we're going to be doing this in college algebra tomorrow? What is that hill called? Not an inflection point. Begins with an M. Maximum. There's a maximum. A hill is a maximum. And if I come over and follow this to 5, Yep, I'm right at 5 now. And I notice what's at 5. A valley is called a minimum. So what we actually find when we take the, looking for the tangent line to be 0, is we're finding where the maximum minimums occur. So that if I now look instead, whoops, it's not what I wanted. I want to get out of the mode I'm in. It's not going to be out either, so let me see. I want to draw another line. I want to draw a horizontal line. And if I go up here to the x-axis, horizontal line has a slope of 0. You notice that at that hill, it's got a slope of 0. And at that valley, it's got a slope of 0. So when I set the derivative equal to 0, I'm finding maximums and minimums. And what you want to do, if you're a business person, is you want to maximize profit and revenue and minimize cost. So derivatives enable you to find maximums and minimums, where they occur, and what the value is where they occur. So the x value would be the number of units. The y value might be the total cost of producing that many units. So you would want the minimum rather than the maximum.